most of Algebra of Functions is just a fancy way of saying performing operations with functions. And so we're talking about addition and subtraction and multiplication. And then it does get a little different when you talk about composition of functions. So I'm just going to do a couple examples here with addition and subtraction, and then we'll move on to multiplication, and then we'll spend a little bit of time on the composition. The first thing to realize is that when you see f plus g of x, all that means is take your f function and add your g function to it. And so you're really just doing a substitution here. So the f function is 2x minus 7, and we're adding the g function, which is negative 3x plus 1. And all we're doing is combining like terms. So f plus g of x is negative x minus 6. And the same thing for subtraction. Just be careful on subtraction because of the subtraction sign. So, but again, we're just substituting in the f function, which is 2x minus 7, and we're subtracting the g function. But again, anytime you have a subtraction sign, please make sure that you're distributing or at least paying attention to it. So, really this is the same as 2x minus 7 plus 3x minus 1. And so f of x minus g of x, or f minus g of x, is simply 5x minus 8. Watch out for this. Too many people miss this because they're not paying attention to the fact that you're subtracting everything after it. So use your parentheses and distribute, or at the very least say to yourself minus a negative and minus a positive. So of course the other two operations that we could do are multiplying and dividing. I forgot to mention dividing on the last slide. But again, f times g of x is just the f function multiplied by the g function. Just be careful that that means that we may have to distribute, or in this case FOIL. So hopefully you remember how to FOIL, right? It's just doing distribution a couple times. So it would be negative 6x squared plus 2x plus 21x minus 7, and then we should combine like terms. You should always be simplifying as far as you can. And so that would be f times g of x. The division one is really straightforward. I mean, for the most part, you're just putting the f function over the g function, and then maybe you can simplify. But when you're simplifying fractions, you have to simplify by factors, and neither the numerator nor the denominator can be factored at all, so there's really nothing else we can do, and that's f divided by g of x. So the final part of the algebra of functions is this idea of composition of functions, and I'm going to work through a couple different ones of these and then show you how it can be used with respect to the idea of inverse functions. So the first thing that you have to understand is this little thing here. This is not a multiplication sign. This is the composition sign. And these two things are equivalent. I personally like this much better. I think it gives you much more information than this, but they do mean the same thing. And please note that the order makes a difference here. F of g of x, and that's how you would say this, is the g function inside of the f function. And we're going to go in both directions. We're going to start with this, but that does make a difference, and so you do need to pay attention to it. So remember that anything that is inside the parentheses on the left-hand side of a function is what you're actually plugging in to the x value of that function. This is an x, but it's also just anything. It's just a placeholder waiting for anything to be inserted in it. And that's, in this case, it's going to be g of x. So nothing is changing from our f function. You know, the rule of the f function still says we take 2 and multiply it by whatever our input is. In this case, it's going to be g of x. And then after that, we're going to subtract 7. So this is just a bunch of substitution. So now that you have it set up this way, you can just say, well, that g of x is really negative 3x plus 1. And now we're just going to distribute the 2. And so then finally, f of g of x is negative 6x minus 5. So let's try it the other direction, where we're going to do g of f of x, but it's the same idea. You know, the g function still says multiply negative 3 by whatever the input is, and in this case it's going to be f of x, and then add 1 to it. So again, all we're doing is substituting now, and we have negative 3 times 2x minus 7, since that's what our f of x is, plus 1. Distribute the negative 3. And we get g of f of x equaling negative 6x plus 22. So there is a variation on that question, and it would look like this. Remember, these two statements are saying the same thing. And so you're just going to work from the innermost parenthesis out. And so, you know, this is really simple because all we're trying to do is substitute information in. The first thing you want to look at is, well, I need to find g of negative 2. So let's go find out what g of negative 2 is. So g of negative 2 is the same as negative 3 times negative 2 plus 1. So that's 6 plus 1, or 7. So really what this question is asking then, since g of negative 2, which is what we're going to plug into the f function, since this is 7, then really what we're finding here is f of 7. Okay, so then f of 7 is 2 times 7 minus 7, or 14 minus 7. So this whole thing, f of g of negative 2 in this case, is just 7. So let's look how we can use composition of functions in order to determine whether or not two functions are inverses of each other. This statement that f of g of x equals x and g of f of x equals x, then they are inverses of each other, should kind of remind you of the fact that inverses reflect over the line y equals x, and so they kind of could make a little, maybe it makes a little sense to you. So let's see what happens when we try this out. So, this is what we're going to test. And remember what that means is we're going to substitute the g function in for any x value in the f function and simplify it down. So that's what f of g of x looks like, so let's simplify it. 2 times 1/2 is x, plus 4 minus 4 is x. So far so good, but it does need to work both ways. So let's test. G of f of x. And so the g function starts out with a 1/2, and we're going to plug the f function into it. And simplify it down to see what we get. So we get 1x minus 2 plus 2, and sure enough that is also x. So since both compositions, f of g of x and g of f of x, both give us an x, we can say that yes, these are inverses. So let's go over one more example of this, and we're going to do composition of functions again to figure out whether or not these are inverses. And we'll try f of g first. So 1/4 times the g function minus 6. And we'll just do some substitution here. So 1/4 times 4x plus 6 and minus 6. And when we distribute that, we get 1x plus 6 over 4 minus 6. 6 over 4 is 3/2. So we would have x minus 4.5. And we can't simplify it any further. And so right away we can say that in fact, to answer this question, no. And we don't even have to try g of f of x because both ways have to produce an x, and this way already doesn't, so it doesn't matter whether or not g of f of x does. We know that these are not inverses.